Hi, my name's Pharaoh, and I've been away for a while because I managed to break my PC. And while I've been away, I've been thinking I really need to sort out the last video in my deep dive for Hyperdrive. Now, if you've seen those before, you'll know that what we were trying to do was fully work out why interceptors seem to have a lower hyperdrive range when we bump them up to S-class and put loads of modules into them, but when they're at C-class and they only have a few modules, they seem to be much better at hyperdrive than anything else, which does give the impression to a lot of people that interceptors are the best hyperdrive ships, whereas they're not when they're fully upgraded. In order to demonstrate that, we were doing a deep dive into exactly how adjacency works, and I was using a spreadsheet to show exactly what the values were, how adjacency is calculated, and down to 2 decimal places we were working out the accuracy of various ships. So here is the ship I was using to test everything. This is an interceptor with a bonus of 8.2018. What we have here are 3 modules. They're all pretty good modules, but they're standard S-class modules. And so we have a hyperdrive range of 220, 228 and 225. And they're actually 224.53, 228.48 and 220.03. And I worked that out through a long period of trial and error, trying to work out exactly how they reacted in different conditions so that I could get a very accurate reading of what these are. So these are modules I know very well, and I know exactly how much they're worth. And the Crimson Core, and as we were discussing in the previous video, the reason that there's a difference with interceptors is because the Crimson Core has a value of 600, as opposed to in an ordinary ship, the warp drive has a value of 100. But then the bonus would be a lot higher than just 8.2. It would be much, much higher than that. What I left unsaid was how supercharged slots work. And so what we have here is an example of no adjacency bonuses at all. I've got no other modules alive. All of my Indium drive, Emerald drive, etc. They're all not included here. It's just a very, very raw calculation based on modules, no adjacency. They're not next to each other. They're separated away. And what I'm going to do is I'm going to move them from this position into supercharged slots. Now, bear in mind the hyperdrive range at the moment is 1378.4, and to quickly explain that as a recap, we can think of the bonus as being a percentage. So if it was 10, it would be plus 10%, and in this case it's 8.2, so it's plus 8.2%, or multiplying the value as seen here, 220, or actually 220.03, by 1.082. So each of these are going to be multiplied by 1.25, or 125% of the value. So we started off with 1,378.452. It came out as 0.5 on the screen, but it's 1378.452. If we then take 1 away and then multiply by 1.25, we come to 1,721.815, and then we add 1 to get 1,722.815, or in this case hyperdrive 1,722.8, because it's rounded just to 8. Now you might think, well, does it complicate things when we use the adjacency? And in this case it doesn't, because everything is worked out from the value of the module wherever it's sitting before we start calculating adjacency. So at that point everything else is the same. So here we have the optimal layout and the maximum possible hyperdrive range we can achieve with our modules, which in this case is just below 2040. And you can see that our supercharged slots are in this dogleg formation, and that's because we're picking which slots in our optimal layout will give the maximum extra. And because everything's worked out in exactly the same way as previously in the previous video, I'm not going to go back to the spreadsheet and look at exactly why we've got this layout. Suffice to say that what we're doing is we're maximizing the actual values, and the three highest values and the things that actually make the most difference are the core itself and the three modules, and everything else is just getting its maximum bonus from those. So if we were taking an interceptor and using it for maximum hyperdrive efficiency, we would have this dogleg system. But of course, what our previous videos have demonstrated is that this isn't the ship to be maximizing for hyperdrive, because it isn't as good as it first appears when you first get one. So let's look at the maximum configuration for an Explorer, which is definitely the ship you would want to maximize for hyperdrive range. So here we are looking at an Explorer, and I would say this is the optimal layout. In the previous video, for some reason, I was going for an optimal layout that was in a square, and returning to this video today, I immediately thought, I'm not quite sure why I did that. This is clearly slightly better. So this is giving us a 0.6 of a light year extra. So it's really not going to make an awful lot of difference. If you prefer a nice tidy square, maybe that's what I was going for. I don't know. But this would be the optimal layout. And you'll notice, as I said in the previous video, that the Atlas figurine does give us a extra boost, but it's not got any adjacency bonus. We can put that anywhere. It doesn't have to be in that particular position. So the notable thing is that for an interceptor, we have a dogleg, but for every other ship that's got a more normal type of bonus, which is usually going to be significantly higher than we want a square. So the ships that we would normally go for hyperdrive distance would be an Explorer in this case, or an Exotic, which has also got a reasonable hyperdrive bonus, not quite as good as an Explorer. And for both of those, square would be optimal. Now we can very quickly work out what the difference would be if we weren't using the supercharged slots. Here we have 2406.6, and here we have 1946. So we're talking about a difference of 460.6 light years, which is pretty significant. So if you really wanted to find a ship that you were using for, say, warping between black holes, or warping to the core without black holes, or just jumping around the map, then Explorers with a decent bonus, and in the previous videos I explained how to calculate the bonus, but an Explorer with a decent bonus would be best configured this way with the hyperdrive set up thus. So there you have it. Supercharged slots, while significantly increasing the distance of a ship, don't change the way we think about the modules in general. They don't change, for instance, how the adjacencies work. They just increase the value of each of the modules before adjacency is applied. And they don't change the layout of our modules, and they don't change which ship we would choose to use. They simply magnify that calculation. Now there's one other thing that maybe I will touch on in a future video. I'm not 100% sure if I'll make this one, but that would be how we might decide for suboptimal supercharged shot layouts. But I think that might be something to look at when I've done a more thorough project, which is trying to work out exactly how damage bonus works, because I'm pretty sure most people aren't optimizing their ships for hyperdrive. They're probably optimizing their ships to shoot things. So when I've finally worked out that calculation, we'll come back and look at that further. That's actually proving quite tricky, because there seem to be some opaque issues with exactly how damage bonus works, and also there seem to be some inconsistencies. So it depends if I can really get to the bottom of those as to whether or not I'll make those videos. But in the meantime, travel well, and goodbye for now.